Can you folks hear me? Oh, now I know they can hear me. I can hear me. So I'm going to give you a quick, one of many hacks that is going to happen in this talk, which is I may use a laser pointer during this talk, and I'm going to use it on this screen because that's too far away. So if you're worried about, I do highlight things in the slides without the laser pointer, so maybe it's not necessary, but if you're concerned about that thing, you should sit on this side. Also, if you didn't see this warning, see, even though it's highlighted, I like to point at it with the laser pointer. There is going to be a bunch of code on slides. Like you may have ever heard somebody say, don't put a bunch of code on slides. Well, somebody also told me you can't put a coffee cup on this lectern, and I didn't listen to that advice either. So there will be some slides with heavy code, just be forewarned. It's not like a super deep technical talk, but you know, it could blur all together depending on how late you were up last night. So we're officially started, right? So thank you for those, if you are too far back and can't read, this is, I didn't know Postgres could do that. I'm your humble host, Robert Treat, for the next hour or so, probably less, or Magnus will get mad. So let's go to, I do a bunch of Postgres stuff. There are two things I want to mention on here. One is working on a Baltimore meetup group. So if you are in Baltimore or know anyone in Baltimore or the surrounding area and they're interested in doing a meetup group, or you used to be in Baltimore and you just want to come back because crabs are good and pit beef is better, please let them know there's a Baltimore meetup group, and I'd love to see them join and come and hang out with us. The other thing I'll mention off of this, there's a project that I maintain called the Gdl sample database. It's like a DVD rental store schema, like that type of thing, which is like Netflix, but through the, you know, like at a location store kind of thing. So I use some examples in this that come from that schema. So if they're like later on, you're like, wow, that was such a great talk. I need to play with that at home. It's on GitHub. Look for Gdl and download that, and you'll have the code and stuff. Also, there's a Slack. So I'm now doing 3 things. I'm going to call it an off by 1 error. There's a Postgres Slack if you're not aware. I'm on there. So if you have questions later, you can find me there and ask questions. Also, some ground rules for the talk. I am at RobTreat2 on Twitter. I'm not going to say that Twitter is a safe space, but if you are on there, feel free to follow me. I'm usually harmless. And I will announce like, hey, slides are up and all that through Twitter. If you really like this talk and you're enjoying it as you're going through, feel free to tweet out like, this is the best talk I've ever seen, and you know, that'll be appreciated. If you hate the talk and you're like, this is the worst talk I've ever seen, my email address is robert.treat@accreditive.us. I encourage very long, lengthy, detailed emails to be sent to me about how horrible the talk is, and then I will take care of those in the most appropriate manner. Couple of website links. I work for a company called Accreditive. They will want me to put these slides online at some point. Probably either on our LinkedIn page, there'll be a link to it, or maybe on the accreditive.com site. We do Postgres stuff, which is sort of where the genesis for this talk comes into play, which I'll get to in a minute. One weird trick that I'd like to sort of suggest, I've mentioned I'll put the slides online and all of that stuff, and I used to tell people that means you don't need to like take copious notes or photos of everything, and that's probably still true, but actually science sort of tells you that if you do take some notes, it actually helps you retain information better. So for this talk, since there's going to be stuff with lots of code and writing that down is very painful, I've come up with an idea that there's one weird trick that when you see this little item on the slides, you'll know write down the words that are on that slide, and then if you need to recall it or Google it later, like that's the thing you want to start with Googling. And so the way you'll see that is, not that I can point to it because the speaker's in the way, there's a little round circle thing in the corner. If you see that, it's like, oh, I should probably write this thing down. So, and if you actually write it with pen and paper, you'll retain it better than if you type it in, which maybe makes no sense to anyone under the age of 40, but science says so, so I'm going to believe it for now. And if you've already checked out of the talk and you're like, it's too early, I stayed up too late, whatever, I don't even know what Postgres is, I am not above just shamelessly saying, I'm going to throw some cute pictures into the thing so that you'll have that to look at every now and then to break it up a bit. So those are mostly the ground rules. A little bit of background where this talk comes from. It's interesting to do this talk at a Postgres conference it mostly came from, I do a lot of work with developers, helping them either migrate applications or make their Postgres applications better. The interesting part about that is that Postgres is very deep and there's a lot it can do and all of that stuff. So we end up having conversations about little things that like, oh, I didn't know Postgres could do that. Like I hear that from folks often, because everybody's sort of on a different learning curve. So this is sort of a hodgepodge of different things that we've tried to teach to developers, be aware of this, also for DBAs as well. I do sort of feel, because we're on the last day of the conference, if you've played the conference correctly, you may have actually heard of all these things already. So that will be interesting to see. But hopefully you'll either learn something new that you haven't seen, or maybe think about it in a different way from another talk that you may have seen. And this is from all over different parts of Postgres. There's not like a rhyme or reason, like it's not 21 tricks with the wall log. It's going to be a bunch of different stuff. So, all right, with all of that said, let's get on to the first thing, which is pgstat statements. How many of you have heard of pgstat statements? Okay, that's most of you, which is good. If you haven't heard of this, then this is one that you should be aware of. The context for this is if you look at Postgres, there's possibly almost an overwhelming number of sort of statistics-related tables and views that you can look at. The most common ones are pgstat activity. That shows you all the running queries in Postgres and what's going on, whether they're, locking is going on or they're waiting on something or whatever, where they're connected from. So that one's pretty common. And then you get into like PG statistics, which is like where they store metadata about the data for your tables. And then there's these other ones that are sort of a little more, granular for tables and indexes and other processes that are going on. Unfortunately, pgstat statements is designed to give you like that kind of information about the actual SQL queries that run in the database. But for some reason, and I'm sure there are good reasons that other people will tell you about, but I won't because I don't agree, this is actually not installed by default. So if you want to see pgstat statements, you actually have to go and install that manually. And now I will tell you the bad reason that they'll tell you is a good reason why it's not in there by default is that it does create a little bit of overhead in the database. So the secret tip for DBAs or developers is when you first stand up the database, install this before anyone looks, because they won't realize that you've installed something and then nobody will actually notice the performance difference because it's really not that significant, and they'll just baseline for that. Also, disk space and RAM is way cheaper than anyone else's time, so the difference that you're going to get off of that, it's worth just installing it and making sure that it's there. I won't go super deep into it. There's like a whole page in the docs on what it is, but just to sort of see, like, there's a lot of information in that view, right? So if you go actually install it and start running queries, you can get all of this stuff. The obvious things are like the user ID is like who's run the query, query ID for the query itself, and that probably it'd be easier if you looked at something to look more like an example. This is sort of a cut down thing because there's a lot of information in there. So as you can see, it takes a query. This is like the simplest kind of query, right? Selecting from the actor table where first name equals something, it parameterizes it, and then starts to collect statistics about it. The nice part about this is if you know SQL, which you probably do if you're doing this, all of this data is now in a SQL format that you can go query and aggregate and do all kinds of tricks with. I ran a few more queries and took a little snapshot of that. And so you can see, right, it's just different queries that are in there and sort of information about it, how often they're run and how much time it took and that kind of thing. So if you're trying to do some sort of like quick profiling on your system, the more common way is probably to use something like pgbadger and download log files and get those processed and all that. That can certainly be cumbersome to set that whole process up. This is sort of a much easier way to get quick information. It's not like the one solution fixes all problems thing, but it certainly gives you like quick access to some information that can be really relevant really quickly. Ta-da! Cats are cute, right? Another one you probably have heard of. I've seen a couple of talks here that have talked about Transactional Ddl. Who has not heard of Transactional Ddl? Okay, nobody wants to admit what they don't know. I like that. You're like the little half. I saw it. It's good. He's honest, so that's a plus. All right, so quick little primer on Transactional Ddl. So the basic concept is pretty simple. If you're all familiar with transactions, probably so. Right, you do a begin, type in your stuff. You can roll it back if it goes horribly wrong. Yay, transactions. The reason why it's significant in Postgres, we can do it with DDL. So you can do something like begin, drop a table. right? Roll it back, the table is still there. If you try that in Oracle, you're in bad shape. And most systems actually, not to pick on them, most databases don't really have this concept of transactional DDL. When you do DDL, there's an implicit commit, and it just has sort of happened. So that's unfortunate. Usually the example you'll see with transactional DDL is this. When people talk about it in Postgres world, it's you could start a transaction, create an index on a table, and then run explain analyze to see if the index actually has helped you, right? And then if it didn't help you, you could roll it back and the index would be gone. I would tell you don't do that. That's really not the right, I mean, that will work. It won't break the system, but like if that was your problem, a better thing would be create the index concurrently, then see if it works, and then if it doesn't, just drop it and don't worry about the transactions, because that'll be less of a sort of an operational hit to go that other route. So while this is a common example that you see, I don't really like that example, so don't do that. A better way to use it, and this is a more common usage as well, would be to do something like multiple create table statements, or maybe like create a table and then another table with foreign keys, and put that all into one atomic operation. Like if you're rolling out a new feature and you need to do different modifications, so you know it's all there or not there. And there's a good debate that could be had at a bar about whether you want piecemeal DDL or not, and we could talk about that. But at least the concept that I can batch sort of multiple DDL statements together and make changes on my database atomically, I think is very useful. The other way that you may want to think about this, you can actually take this even further, and that's one of the really nice things about Postgres that we try to sort of impress, and you'll see this in the talk, is that usually parts of the system that work for like a certain case, as we introduce new cases into that, you can use them in the same manner. So here what I'm doing is I start a transaction, and then I do an alter table on a particular table, right? And let's say I decide family name doesn't actually make sense in a context of more than like people from mid-England 300 years ago. So if I rename that column, I can actually put a save point in the middle of that transaction as well, right? And so if I wanted to, I can do a change on my system. I can actually insert like mock data and test data and select that back out and see that everything is working the way that I expected it to. And if there is a problem, I can roll back to the save point. Well, let me rephrase that. If it works and those tests actually pass, I can roll back to the save point and then commit that data, and then the table changes will be there, but the data that you've done for mock testing will not be there. So you can actually run that in a production setting and sort of verify that the thing actually works without having to commit it. And that, I think, is like really powerful, because usually, even with the transactional stuff, you're like, well, if I have to commit it and then test it, what happens if it's bad? Now I got to have a migration to roll it back and drop tables and stuff. Yeah, you can use save points right in the middle of that and sort of do that same thing. If it did go horribly wrong, right, and those tests failed, you can certainly roll back the whole transaction, so that will work as well. But that's sort of a really neat trick that you can do if you want to do a little bit more testing on the system, still within the safety of a transaction. So that's, I think, sort of a more advanced, but I think a better way, and sort of ways to start thinking about how you can layer some of these tricks together. This is not code that is related to Postgres. This is what happens when you type in like computers into an image search engine. You get this back. So there's a slide for computers. All right, insert returning. How many people are familiar with this? Ooh, okay, we got good, because we're going to build on this one. So this one's definitely a little circle in the corner. This is one that you should know. Here's the basic sort of simple example. Some days I get illusions of grandeur and think I'll be famous or something. So here I'm inserting into a table, actor, putting in my name. I'm doing this returning star bit, which is right there. And that piece of magic basically says, when I do the insert, give me back the data that I've just inserted. And the reason why that starts to be powerful is normally the pattern is like, I'll go do an insert, but then I have to go back and do a select, right? And I have to get some piece of information back anyways to know what to go and select back out. In this case, you can see the only two pieces of information I passed in were my name, right? So I got my name there, but when I do returning, I can get back other fields that are auto-generated from that result set, right? And so that's basically one round trip to get all the data, whereas otherwise, without returning, you've got to do at least 2 trips, if not possibly more. So that starts to become a very sort of interesting feature. You can build on that. Of course, this also works, and this is another thing with Postgres. We try to sort of make this stuff work in all the cases. Here I'm doing an update. So here I've changed the first name. I've had some actoring success, and so I need to be more formal now. I want dramatic roles. So I changed to Robert. You can see I got the update time, even though I didn't know it. But also, I'm claiming I don't need to know the ID because I knew the ID to begin with, right? I've passed that in. So I can specify which columns I actually want to get back. So if I didn't want to get everything back, I wouldn't have to. I can just sort of nitpick which pieces that I want. And of course, just for completion, this also works from the delete side of the equation as well. If you're deleting stuff out of the table, you can get that information back. Yes, ma'am?
I'm actually just wondering what's so bad about doing two statements, like doing something and selecting from that.
I'm not going to say it's a moral failing or anything. Mostly, if like for performance reasons, would be the first thing, right? They're like 2 round trips across your system versus 1 round trip to do it. That's sort of the immediate benefit. I do think also it can simplify code in a bit. And then I guess the sort of third reason, which you're not supposed to say, certainly not in a recorded talk, is that this feature isn't supported in many databases. So if you write your application code this way, it'll be harder to port it out of Postgres. So that, I think, is actually a feature, just something to think about. It is I believe SQLite will support that syntax. So, Richard Hipp is a nice guy, I guess. So maybe that's good. You can claim it's portable without actually having to worry maybe of where it's going to get ported to. And so there's going to be some other tricks I'm going to show you in a minute here that also will build on this. But even just the base sort of functionality is there that you can sort of see like, oh, this might be an interesting way to deal with things. So we're in a city. This is not the city that we're in, but we're in one. All right, CTE returning. We're going to combine a couple of things. How many people know what the words, or it's not really a word, the letters CTE stand for? All right, yeah, we got some out there. You're all liars. Sure, one or two of you probably saw this earlier in another talk maybe. So CTE stands for Common Table Expressions. Again, note the little dot that I can't point at. If you go to look this up, in Postgres world, we pretty much always shortcut that to CTEs. If you look for common table expressions, you'll see it talked about in other databases. And so just be aware of that, but that's sort of the more real name, if you want to call it that. So I'm going to give you a little example here of what one would look like. And I'll walk you through this. I don't know that it's complicated, but why not? So CTEs basically start with this clause. And actually, if you're going to look up documentation on this in Postgres, this is basically all under the select clause is where you'll actually find this. But it starts with this idea, with, underemployed, as. And what I'm doing is I'm naming what my common table expression is going to be. And then my query, which is not like a crazy thing or anything, but basically I'm just trying to get all the actors who have never worked before. So I have a table called film actor that matches all the actors to a given film. If you're an actor and you've never been in a film, then I would say maybe you're not good at your job, but that would be unfriendly. So I will now say you're underemployed, and people should make better use of your skills. But in any case, so I can name that common table expression and then pull my group of data out, and then you select back from whatever it is you've named and what you've built in that common table expression, right? So I'm doing select all from underemployed, which matches up above. There only happens to be one person in this data set that fits that, which is Tom Miranda. Ironically, his actor ID is 42, and I don't know if that means anything, but it kind of thought it was interesting to me. That's the basic sort of gist of it, and you might look at this and say, well, that's not super interesting, because if you had just done the select query, right, this part that's in this like sort of set of brackets, like you would basically get the exact same result set. So this in and of itself is really not that interesting, but hopefully it will get more interesting in a minute when we do something like this, which is CTE returning, right? So that idea that I can mix and match insert returning and update returning, I can put those in a CTE, and now I can really start to do sort of exciting or interesting or complicated things. So here what I'm doing is I'm building out a different query and a different sort of set of data. My overall goal is I'm looking for films that I've not been able to rent out. And I've decided I might as well get rid of those. There's no sense in taking up inventory. Because this is actual DVDs, they take up physical space, right? If this were Netflix, we wouldn't care. We would leave them in. But this is from the 1900s. I call this RIP, because these are the movies I'm getting rid of. And then I define how I want to do this. And there's a little bit going on here. So I'm deleting from the inventory table where the inventory ID is not in the rental table, right? So in this query, the delete is actually going to happen. Those rows will be removed from inventory. I need that result set back, though, because I want to put it into another table, right? And I'll then do an insert into giveaway. So I make a new table that's going to be the DVDs I'm getting rid of. And so that's going to be everything that was in sort of that RIP query, right? It's going to get inserted into the giveaway table. Now, I'd also like to see that as an application developer. I'd like to see those results back so I know what I've just put into the table. And in this case, I can do the returning again for the outer query to get that back. And so I only had one, but that was the one I was going to give away, right? So as you start to sort of daisy chain these things and layer them in, like, you sort of looked at that. This is a good question for, like, if the original returning was like, I'm just going to save one round trip, but now, traditionally in an application, probably this would be, a select to actually find the number of rentals that I wanted to get rid of, and then I would do another query to delete them, right? And then I would take those and insert them, and I'm not quite sure how I would manage that, and then I would want to select that back out to get them, so you might be saving 4 or 5 round trips. The other part of that is, if you were doing this in multiple steps, you'd probably want to wrap that in a transaction to make sure that they all happen together. In this case, it's all one statement, so there is an implicit transaction that is put there, but you don't actually have to really deal with transaction management, right? It just all happens in one atomic step, and either it's good or it's bad. And from that standpoint, I think you get simpler code to look at, presuming you find SQL an interesting language to deal with. So hopefully you do, or you may be in the wrong profession. Just saying. So that's CTE returning, and we can take this even farther, and we will. But first, we maybe need a break, because that was like 4 different things layered together. There are beaches nearby. None of them look like this. But there are beaches. Range types, I'm pretty sure I saw a talk earlier that talked about range types, and then somebody asked about it, and I don't think there were examples in that talk, so hopefully that person is still here in this talk, and they will see an example. People know range types? Yeah, we're down with it. Who uses range types in production? Oh, that's a different question. Yeah, see, there you go. We're cutting the numbers down. So I will pretend like that means more people are learning. I feel good about that. So taking my rental idea, right, I've got the basic concept of I've got a rental date and a return date, right? So the first is like when I've taken the movie out, and the second is when I brought it back. Now, the old way, I guess, right, the legacy way, is I would have 2 different dates for that. And if I were going to do sort of statistics and analysis on that, like, I can get it done with those 2 different dates, right? I'll do a lot of between queries and like greater than, less than magic and all of that stuff. But if I wanted to be like, a little more hipster, which who doesn't want to be more hipster, what I could do is I could change those into a single column called rental period. Right? And so here is the example. I just added that column onto the table, and then I use a thing called TS range, right? In red, which is basically timestamp range, right? So there's different kinds of range types that are out there. So when you see the concept of range type, it is a little more dependent. It's not like saying an integer array versus like, character string array or something like that, where it's take a basic type and make an array out of it. In this case, you do need sort of some special machinery, but there are multiple range types that are already built into Postgres. Date is one of the more common use cases, which is also why I picked it here. But I could add that, and you say, okay, well, I've got the column there. If I then wanted to do conversion of the data, or what does it look like to put data in there, for conversion purposes, and I actually probably could have done this all in one thing, but I wanted to sort of split it out. Here I'm updating that table, right, and I'm setting the data in there, the rental period, using the TS range. I'm basically casting it to a new type that's going to start with rental date, which is when, this is when it was taken out, and then the end point of the range is when it was put back is the return date. And so now you would say, what does that look like? And if you heeded my warning earlier, you can read this, right? And if you didn't, and you can read it, then you've beat the system. But basically, so the data looks very similar. I've got a rental date when it's taken out. Return date is here, because that's the old data. And now if you looked in here, you would see here's the range of data. And just looking at that, it's sort of like, well, OK, I don't know if I really want to deal with that. It looks very similar. What is the advantage? And for many basic operations, I'll be honest, like I'm not sure there is, but as you start to get into sort of more complicated questions that you want to ask about data, it does certainly make the SQL simpler to write, provided you can maintain the concept of the right operators. And I'll give you an example of that. Here's a question that is pretty common that you might ask in this scenario, and probably people get asked these kinds of questions, right? How many movies did we have rented out on June 21st? And if you have to do that with a rental date and a return date, it's a much more complicated statement. Whereas in this case, there's a contains operator, which basically just means if that, if the range of data that is in my range type contains the date that I'm asking for, then that means it was rented out, right? I don't really care what day it was rented on or what day it was returned. I just care that it was rented on that day, right? So I don't really care about the boundaries of the range. I just need to see that. And so this is a pretty simple query. The only hard part, is knowing that this little bird-looking thing, like that means contains, right? And if you remember that, like that's the good part. And it turns out we've documented it. So if you are working with this, you can look that up, like I did when I made that slide. So that makes those kind of queries much easier to do. Yes, ma'am? That's, it depends, I guess is always the ultimate database answer. Generally, it should perform, I would say, as well or faster. You can also index this as well, and I actually would tell you, I think it's easier to index this than it is to do the other thing, because in the other case, you definitely have, it's like greater than, less than, which will then depend on where that falls in the overall scope of data, and you need multiple indexes on both of those conditions to try to capture both sides of the equation. Whereas in this case, you basically would just do an index on the range type on that one column, and then it can use that index for that. So I think generally I wouldn't expect a problem performance-wise. It should be about the same, and if you need to index it, it's actually easier to index. So another sort of example, if you're thinking like, okay, what other kind of reports do I need to do, and that kind of thing. A different question, but a similar one, how many movies did we rent during the entire month of June? So now I'm looking for within, as opposed to contains the data. I'm looking for was it within this other range. And it's a very similar looking query, right? Just give me a count from rental, where the rental period, so that's the range of the rentals themselves. And then this little double ampersand deal, that means within, obviously. It's almost like a mnemonic, right? So that's within, and then I just pass in a range that I'm looking for. In this case, I'm like anywhere in the month of June. So now I don't care when it was first rented. If it was rented before the month of June, that's fine, right? And if it was returned after the month of June, that is also fine. But now I know how many rentals I had during the month of June. And again, I mean, you can work that out with, greater than, less than syntax and that kind of thing. But I do think it gets a little bit easier maybe to do that if you have using the range types. You can also build on that to do like constraints and that kind of thing. So if you want to make sure, that people aren't like renting the same movie at the same time and stuff like that, you can build all of that in. Again, the features that Postgres tends to add, they work with all the other stuff that's already existing, or certainly strive for that. And because you said the word performance, I put in this slide about moving super fast. See, it's very good. Yes, sir. Yeah, again, it depends. I'll probably say that for every question. It always feels that way. I think the temporal extension does have further capabilities than what is built into core, right? The person who worked on putting it in core also worked on the temporal extension, and it depends on the version and which extension you're using. The older temporal extensions were sort of the precursor to this built-in stuff. So if you're just using sort of the basic functionality, I think all of that actually is in core now. And you can use it within core. And I think all of this is probably in since 9.6. I know it's there for sure from 10. So you may have to look and just sort of make sure that that's there. Certainly I would look at that. But I do think there's some additional stuff that might be in that extension. So if you're using like really advanced features of it, then I think maybe that is not necessarily in core itself. But I'd have to double check that to be sure, because it's a little bit of a moving target. So, but yeah, no, that's definitely a good question. Here's the thing I know, again, I saw this in an earlier talk. How many of you went to a talk on foreign data wrappers? Yeah, I know you did, because I said it in your talk about it. So that was a good talk. And I thought about taking all these slides out and just putting a link to her talk, but I didn't do that because I thought that would be more work. So since I already had them written. So let's talk a little bit about foreign data wrappers. I'll start with the basic premise for those that are unaware, is it's basically a means for Postgres to talk to other systems. If you've ever read the SQL Med standard, right, there's a part of the SQL standard called SQL Med. This is not exactly that, but, and that's, I'll buy you a beer if you've read that standard, because it's really awful. But this is sort of going in that idea of like, we want to talk to other systems and databases and files and Twitter and whatever. And foreign data wrappers allow you to connect from within Postgres to other systems. It's usually pretty easy to install. With most extensions, like we mentioned, like PG stat statements is pretty much everywhere, and you can install that. This one will kind of depend on what you're trying to connect to. If you've ever had to deal with like ODBC life or JDBC life, where it's like it depends on the driver if it's available kind of thing, foreign data wrappers can be that way. There's a built-in one for Postgres that should be really easily accessible for you in your installation. You should have that one. If you're trying to connect to other sources, that can be different, and there are a whole bunch of them for all kinds of stuff. But it's just like the sort of simple example, walk you through this. You create a server. In this case, I've called it legacy. Let's say I'm going back to an old system, and you create server legacy. It's a foreign data wrapper using the Postgres foreign data wrapper, so I'm connecting to a Postgres system. And then the options, you can put in all kinds of stuff. This is basically just, I'm super hip. So I'm connecting using IPv6 for performance reasons on my laptop over to another version of the database that I had running, right, to a copy of Pagila. And so I can make that sort of external connection. You then create a user mapping, so you can control sort of at the user level how you want to connect to the other system and make use of that. Here, again, I've just sort of done the simplest thing, but you can sort of add more pieces into this for the options piece. And there is definitely extensive documentation on all these commands within the Postgres docs. A simple looking thing would be you make sort of this foreign table, right? It was going to be a reference that you then define what is the table going to look like on the local side, and it's going to connect over to the other side and get the data. If you think about that, like in the Postgres sense, it's very obvious. In like, if you thought about this, you can do the same thing for like a CSV file, right? Create a foreign table and then point it at a CSV file, but you still need to define to Postgres what is the data type's going to look like for that, right? And it gets even weirder. Like there was, I don't know if it's still maintained. There was a Twitter one, so it would actually read from Twitter, and you could do that within your Postgres. So, but again, you have to define what is that data type going to look like in a Postgres system. But here I'm connecting to the server legacy, right? And then I throw in, this is where I'm defining what does the table on the foreign side actually look like. So you can sort of mix and match. You don't have to make it all the same. You could also put this in its own schema and then have it mirror the schema from another database. So those are some options as well. And so you can do all kinds of sort of tricks. Here, my legacy rental tables, when you actually go query on it, it looks just like you're querying a local table. Data is not so much important here, but you can see this is definitely old because it doesn't use the timestamp range. It uses the old return date and all that. So again, here's a simple select. What does that look like? The one caveat I'll give, be aware performance-wise. When you do this, performance does depend on sort of what is it you're grabbing from the other system and what do you attempt to do with that data. In the explain plan, I'll just like, I'm doing a foreign scan over there, right? And sometimes you can get good performance, but other times not so much. It does depend on where you're querying. Imagine if you queried, like in this case, I could scan over on the other system and maybe have qualifications pushed to the other system, and it might be a quick query. But if I'm querying something like a CSV file, it doesn't understand the concept of indexes or anything like that. So when the query gets to that other file, it's basically just going to read the whole thing and pull it back, right? Against a Postgres database, it can certainly be smarter. But just be aware of that. If you start to build out on this, look for performance and how that works. And I could go like deep enough into this to do a whole talk, and I know that because there was at least one other talk here that was just about that. But I'll stop it there. Just be aware that there is this idea. If you need to connect to external data sources, take a look at foreign data wrappers because it's a built-in way to do it, and the performance of that is pretty quick. Certainly better than other options that are out there for doing that type of thing. There are no mountains in Florida. Just saying. All right, running total. This is a common one that I see people write a lot of application code to solve this problem. It is actually pretty doable in SQL. I'm going to walk you through this pretty quickly. I'll walk you through it, and we'll talk about a few things. All right, so basically, this is my query. It may look sort of complicated, but I'll walk you through it, and it's pretty similar to what we've been doing before. So here I've got the actual data, so you can match this up. Basically, you start with a select statement, right? Just doing a little bit of cleanup on the payment date, which is reflected down here. I don't need as granular, like to the 6th decimal timestamp in this particular report. Otherwise, it won't fit on the slide, so I have to clean that up a little bit. Then I have an amount, right? So I'm basically asking for people's prior spend. When they go and they rent a thing, I want to know how much they have rented in the past, right? Maybe I would give them like a discount or whatever, look at their loyalty setup or whatever. So here's the amount. This is normal. This is what the amount was of a given rental, right? That one-time thing. And what I'm trying to get is, as I'm getting over here to the running total, I do a little bit of cleanup again. So as I'm summing these amounts, as I'm going along, in the first case, the first time somebody spends money, they've never spent anything before. Normally that would give me a null, but as we all know, nulls are evil, so I need to not get a null there and make it pretty. So I have a 0 here, and that coalesced. So the only reason it's there is to make that look pretty. So yay. The real magic is in this piece. And again, this is one of those topics. It goes very, very deep and is very, very scary. The resource I would recommend to people, and maybe I should put this in this slide where I have a thing and I say write this down, is that there is a talk that Bruce Momjian gives on this, which is actually the best one that I have seen, which doesn't mean there aren't better ones, but it's really good. But it takes him about an hour and a half to get through it, and it's a 45-minute presentation. So it's long and deep, but very good. As you start to get in this, if you get lost looking through the docs, like that's probably the next thing I would go look for. But anyway, so the goal of this is, again, I'm taking a sum, and then I'm just sort of adding it to the previous rows, right? That's the basic concept. And like I said, without going super deep into it, I'm defining these sort of partitions of what I'm looking at in my data. I need to order it by the payment date because I want to total things right in one particular direction. And then you make sort of a boundary of like, where am I looking at? And this is like, I want to look at the row before as I'm totaling these up, right? So from a data standpoint, first time in, $4.99, my previous amount is 0. Second time I spend $2, right? And basically my prior spend should match that. And then when I come back, I'm doing a $7 spend, but my prior spend is $4.99 plus $1.99, right? And on and on and on. So that's the idea of that running total, that you can compute that out. This whole thing is under the guise of window functions. That's the thing, if you were going to Google and look for documentation on it, that's what you'd want to actually go look up is window functions. This particular type of problem, the running aggregate, right? Like that's it's sort of a data thing, but the way it's implemented in SQL uses window functions to do it. And you can do this over sort of large periods of time. Part of why I think this is a good thing to know, and I think people always look at like, well, maybe this is complicated SQL. It's certainly starting to get there. Is it worth it? If you were to say, well, I will just take the data itself and I will do this in my application, right? So just give me all of these individual purchases amounts and I can compute the running total in my application. You could do that. And that might even be the right answer for you. But just to be aware, on this particular system, when I run just the query to get all the data without the running total of it, right? Just to give you all of the actual sums of the rentals back, or the non-sums, just the individual rentals back, it cost me about 97 query dollars, right? So that's the total at the top. So around 100 mythical bucks to run that query. If I give you the running total along with that data, the plan would look like this, right? So it's 97 query dollars here. That's the old query. The only thing I've added is this top piece up here, these 3 lines on the explain plan side, and it only cost me like $2 more, right, of my magical query dollars. So as a percentage, it's like 2% overhead to get all the computation with the data that you're going to need anyways, right? So think about writing that as application code is not necessarily trivial, right? Like, I mean, it's not like impossible or anything, but it might be easier to just do it in SQL and get the data back and be happy with it. And performance-wise, it certainly is not that expensive. And obviously, like your mileage may vary, but from that standpoint, you can look at those explain planes and see, like, as a percentage, it's not that much overhead to do it that way. I think we're getting close to nighttime, right? Because the talk is getting towards the end of the time. And so nighttime looks like this, but not in Orlando. So let's talk about running aggregates, very similar to doing a running total. I have a very similar looking query that is only slightly more scary, I hope, than the last one. But I will walk you through it, and you'll see this could be friendly if we pretend that SQL is friendly. How many think it's a simple query language is what SQL stands for? Nobody's raising their hands. That's concerning. Okay. Just wondering. All right, so let's walk you through this. Again, it's very similar to the last one. We start with, we're doing our CTE. How many people remember CTEs from earlier? How many people remember the cute baby from earlier? Okay, it's about the same. All right. So we do a rental. We're sort of defining that at the top. We do a query. How many people know about generate series? Oh, so this may be the most important trick, which is why there's a slide on it, with a dot, in fact. So there's this thing called generate series, and basically all it does is it generates a series of items. The initial version just generates a series of numbers, and you can actually use that. Just with that alone, you can actually make Postgres Turing complete, but it's a little bit complicated. So you can use this sort of more friendly version to do things like give me a series of all the days in a given month, right? So here I'm using generate series. I pass in the first day of the month, the last day of the month, and I say I want one thing for every day. I could do that for hour, I could do it for week, whatever it is, right? And so now I basically am making a virtual table of sorts, which is one row for every day in the month. And then I want to join to that. So I've got a list of all the days, and you can think about it conceptually. Whoop, over here, I'm going to left join my actual payment data into that. And the reason I'm doing that is there may be days where nobody actually bought anything, right? And I don't want those missing from this report that I'm going to make. So I need some way to make sure every day actually exists, and generate series is the tool for that. It's really good for if you're doing like partition management and things like that, being able to ensure that you have every day in there and you're not like missing a day or doing a gap that might otherwise throw off your information. I need to take the payment date though and join it on a daily basis, so that's why I have this date trunk in here. There are other ways to do that, but I like that one. Then, as before, right, I'm doing sum on the coalesce of the amount, that little trick, because I don't want the null, because nulls are evil. I call this quid, because like everyone knows what quid is, right? It's like money. Use like ducats or something, dollars, I don't know, pounds, yeah. Well, that starts Brexit conversations. We can't use that anymore. Anyway, so that's where the money is going to be. And then I'm doing a group by on the day because I'm doing aggregates, right? It's a sum, so I have to group it by the day. I want all the spend on any given day. I order it because I want to do some more work on this, and I'd like it to be in the right order of the days. And fun fact, if you do something like a sum, or really any sort of group by operation, Postgres doesn't guarantee it will be in order. It probably would have already been in order, but I like to make sure, especially in this kind of a query where the ordering really does matter. Once I've built that, right, and some people would consider like the CTE builds like this temporary view. I don't exactly like that term because it's not a view, but now I sort of have a table that I could work with, like a sort of regular table conceptually. So I can now do that like partition stuff on what I've built with my CTE. And so here again, I'm pulling the day out and just casting it to date. This is the same thing as doing date trunk, but I'm just doing it a different way because it's a conference and you want to show different things. So that's like a shortcut for just take my day amount of data and make it a date. Got my quid, because you got to get your quid. And then I'm grabbing the quid over T, and T is going to be this window that I'm going to define down here, which looks like the previous thing. What I'm actually trying to do, the point of this report is I want to know sort of a 7-day average of how much money is coming in or not, right? And it's going to be a sort of a running 7-day average across the month. So I'm grabbing an average of the money, and then this between 7 preceding and current row basically means look at the 7 days before and the day that I'm in now, right? And do the average of that. So I cast this to float too, because that looks like money. If you ever have a chance to use the money type, only do it if you're leaving your job within the next 2 weeks and you hate whoever's going to take over, which is shorthand for don't use the money type. Use something like float2 or whatever kind of casting you think is good. But I went with that. From rented, right? Rented was my CTE, so that's the sort of virtual data set I'm coming from. And then again, because I'm sort of doing this one at a time, so look at the previous rows and then grab the current row, and we'll pull all that together. All right, that was a lot. I know, it was painful. In the end, this is what you get, though. So there's a payoff at the end. And if you look at this, so again, I had days that didn't have anything. And so for a 7-day running average, here I've got, just so you're following this is the amount of money on a given day. This is the total amount of money that I've spent, like sort of month to date type of thing, right? And then the last one is the 7-day average. So in the beginning, if I didn't do the generate series, like these rows wouldn't even be there. And that would be a problem. But since I did it, those rows are there. And then you can see the sum just kind of builds and builds and builds based on what was over there. And it always gets bigger or stays the same if I didn't sell anything here. My average, though, as you would expect, like it can only sort of grow as fast as it can grow, right? And here it's 54. I look back at the 5 days and sort of average that out. And I can see that that has gone. And as your spend stops, once it stops, as you would expect, the average moves back down, right? Because it's a 7-day running average. So if you look at that, like you can start to build dashboards, you know, and I'm getting like both those pieces of information all back in one query. You can build pretty complex dashboards doing, you know, various statistics things. You don't actually have to install R to get statistical information in Postgres, but you can, which is nice. But you can do some pretty complicated stuff and pretty deep analysis just with the SQL alone. And again, it's all pretty performant. This is a Postgres conference, so I have to have at least one picture of elephants. I am basically at time, so I'm going to say thanks to everybody. Again, if you want to email me or have questions, feel free to do that. I will post the slides. And I think that's all I need to say. Cheers. Thanks, everybody.